Okay, so let us look at a couple of problems related with continuous random variable. Look at the first one. So I choose a real number uniformly at random in the interval 3 to 6, and I call that the x. So find the CDF, and then cumulative distributed function, and then find the expected value e of x. Okay, so those are the two questions. Part one, we know that for all the x in a uniform distribution, the probability for each point is going to be 0, right? And also the uniformity tells us that the probability of an interval inside of this is going to be proportional to its length, right? To its length. So what we can tell is, the probability that x belongs to 3 to 6 is equal to 1, right? So what do we can tell? Well, we can tell that is, the probability that x belongs to the interval, let's see, from x1 to x2, it's going to be, again, it's going to be proportional to its length. Okay, so it's going to be x2 minus x1 over 3. And provided that, we let x1 less or equal to x2 and it's bounded inside of this interval. Okay, so that's something what we can observe. So to talk about the CDF, the cumulative distributive function here, we know that the definition, which is defined as the probability that x is less than s, right? That's all equal to s, okay? And then what we can see is, when when x is less than 3, then you see that the CDF is going to be 0, right? Because the probability that x is less or equal than 3, so always it's 0. Meanwhile, if x is greater or equal than 6, so the CDF kind of equals 1. So in other words, when x is greater or equal than 6, the probability that x is less or equal than 6, for sure, right? It's going to be 1 for sure. What is the situation that when x is greater or equal than 3, less than 6, as you can see, this CDF is going to be the probability that x is less or equal than x, right? But meanwhile, you see that is exactly the probability that this belongs to the interval from 3 to x, right? Because under the situation which x is greater or equal than 3 already. So since we know that that probability is going to be proportional to its length, so it's going to be x minus 3 over 6 minus 3, which give us is x minus 3 over 3. Okay, so easily we can write it down what is the CDF. So it's going to be, as you can see, 0 when x is less than 3, x minus 3 over 3 when x is greater or equal than 3, less than 6, and 1 when x is greater or equal than 6. Okay, so that is the corresponding CDF. Okay. Okay. I think there's somebody is talking outside, so I'll just wait a second and then we'll move on. Okay. So that's the first part. And then to find the expected value, noticing that we're going to need the PDF, right? So noticing that the PDF is going to be the derivative of the CDF. So easily we can figure out that the PDF is going to equals to the derivative of those both parts is going to be 0. The derivative for this piece is going to be 1 over 3, right? So when x is greater or equal than 3, less than 6, and 0 otherwise. Okay, otherwise. So that is the PDF here. And then if we're looking for the expectation, noticing that we can just write it down, follow the definition here. So the expectation is from negative infinity to positive infinity x, and then dx. And easily you can see that it's going to be from 3 to 6 x times a third dx. And then that part should be very straightforward, right? So it's gonna be 1 over 3 times x squared over 2 evaluated from 3 to 6. So as you can see, it's a 6 squared over 6 minus 3 squared over 6. So it's 36 minus 9 over 6. So it's gonna be 27 over 6, or you can see it's 9 over 2. Okay, 9 over 2. So that is the expectation. Okay, as you can see that this expectation, which is exactly the middle point. Okay, so that's the first part.